So I mentioned to you this effectiveness NTU method. We use it primarily for finding outlet temperature, but this is actually not fully true. The truth is actually you can also use effectiveness NTU method to calculate area as well. These are called inverse correlations. So basically, if we rearrange these equations that we have here in terms of NTU rather than epsilon, if you rearrange this equation, these are called inverse correlations. So you can actually find the NTU. This hides the term area. So that means actually I can use effectiveness NTU method to calculate area using the inverse correlations. So basically this can do the same thing with LMTD approach. So LMTD approach and effectiveness inverse correlation with the effectiveness method does the same thing. They find the area. So again, we have inverse correlation for parallel flow, counter flow, cross flow. One is for two cases, both fluids unmixed. One is mixed, the other is unmixed, and shell and tube heat exchangers. And if you have a phase change, NTU is given here. So in all, so that means effectiveness NTU method is more flexible. It can actually do both ways. So, okay. So if we are trying to find the area, if we know all four temperatures, we can calculate MCP delta T. That is step one. So if you know MCP delta T, that means you know Q. And if you know CPs for cold and hot side, you can calculate Qmax. So that means you can calculate epsilon. After you have epsilon and CR, you calculate NTU. NTU is a function of epsilon and C over CR. Then after you have NTU, you calculate the area. So that is basically another way to calculate area aside from LMTD method. The final example that I'm going to solve about the effectiveness NTU method is, so I would like to use effectiveness NTU method to find the area of the heat exchanger. So that means I need to use inverse correlations to calculate area. So I do know the temperatures of inlet and outlet for cold water and hot water, and I'm trying to find the area. So we solve this problem with using the LMTD approach, but I'm going to repeat the analysis with the NTU method. Okay, let's do that. So we already solved this problem with the LMTD method. So now, we are trying to find AS and L using the effectiveness NTU method. So what am I going to do? So first I need to calculate C hot, which is, or C cold, CP cold, and C hot, the capital C hot, M hot, CP hot. So the cold flow rate is 1.2 kilogram per second. This is the cold. CP, we use 4.31 kilojoule per kilogram per Celsius, which is 8.62 kilowatt per Celsius. For the hot side, we have 2 kilogram per second, and heat capacity was 4.31 kilogram per Celsius. Sorry. So the cold is 5.02, hot is 8.62. This is greater. 8.62. This is 5.02. So that means C main is C cold, which is 5.02 kilowatt per Celsius. That means C max is C hot, 8.62 kilowatt per Celsius. So that means the capacity ratio, CR, is C main over C max, which is 5.02 divided by 8.62, 0.583. So we have the capacity ratio. So now I calculate Q max, which is C min top multiplied by T hot in, T cold in, 5.02 kilowatt per Celsius. T hot in is 160, T cold in is 20. So if I multiply these two, I get 702.8 kilowatt. So now I need to calculate Q actual, or just Q, which is MCP T cold out minus T cold in. And I know all the temperatures here, right? So that means I know the mass flow rate 1.2 kilogram per second. I know the heat capacity for the cold side 4.18 kilojoule kilogram per Celsius, and hot cold in minus cold out. So I can calculate this to be 301 kilowatt. So that means epsilon is Q actual over Q max, which is 301 kilowatt divided by 702.8 kilowatt. The ratio is 0.428. This is the effectiveness. So my goal is to find the area. So I need to find the area which is coming from NTU. So I need to use the NTU equations. To find I need to use inverse correlations to find NTU. So the flow geometry is given. So we have cross flow, right? So the counter flow. So we have the counter flow given. So our goal is basically use this equation. So we have counter flow. So we'll use this equation. And in this equation, epsilon is given 0.428. CR is given. So we actually calculated it 0.583. So that means I can calculate NTU. If you do the math, you'll get NTU to be equal to 0.651. So definition of NTU is defined as U times AS divided by C min. So that means AS is NTU times C min divided by times U. So NTU we just calculated 0.651. C min we have 5.02 kilowatt or 5020 watt per Celsius. U is given 640 watt per meter square per Celsius. So AS is 5.11 meter square. And after we have AS, L is equal to surface area divided by pi d, which is 108 meter. So we get exactly the same answer. So this means I can use inverse correlations for any geometry as long as we have this table available to use. We can use inverse correlation to calculate area as well. So with using the inverse effectiveness method.